In this video, we're going to talk about how to solve systems of equations through matrices. And rather than doing them by hand, we're just going to go ahead and use the TI-83 and 84 family of calculators. If you happen to have a calculator that is not part of this family, the concepts are the same. You're still going to have to transfer the system into a matrix, and you're probably going to have to go through roughly the same commands. It's just that the button presses, the key presses that you have to move through, are going to change based on your calculator. So, just a quick update on matrices. A matrix is nothing but an organized structure. Okay, and so we have an array. That array is built of columns and rows. In the case of this system, we have three rows, one for each equation, and so we have 4 columns. 3, one for each variable, and a 4th, one for the answer. So this is going to be called an augmented matrix. The augment is this answer column here. You don't have to have an augmented matrix in order to work with matrices. It's just the way it works for the systems. So all we're going to do is, instead of putting all this junk into our calculator, we're just going to go ahead and put in only the coefficients, but in their same spot. And so I've got a 2 for my 2x, I've got a -3 for my minus 3y, a +1 for z, and an 11. Okay, we're just going to continue this right through the system. It's important to write this step down, that way you know what to put in your calculator by looking at it, rather than trying to translate the system to a matrix into the calculator all at once. Now, if you're missing a variable in your example, for instance, if z was not in the bottom here, I would just put a 0 in its place, because I really have just 0z. And so as I go through, I need to make sure. So I'm going to check my columns now. So I have 2, 3, 1, 2, 3, 1, -3, 2, 5, -3, 2, 5, 1, -2, 2, 1, -2, 2, and 11, 3, 2. And so I got my matrix set up. Now, after we put it into the calculator, we're going to let the calculator do all the work, all of it. Some people might argue with me and say, oh, well, you need to have the students do something. Listen, if I'm going to use the tool, I'm going to use the tool. So I'm not going to sit there and say, hey, you can dig a basement with a steam shovel right up until you hit about 4 feet deep, then you have to dig by hand. No, I'm going to use a steam shovel for the whole thing. I don't want to do all that work. So the answer, what are we looking for? What are we hoping for? The answer, at least that we're hoping for, and we'll get to what happens if it doesn't work like this, that you have 1s down the diagonal, 0s everywhere else, and that's for our systems. Now for the answers, we're just going to have an x value on the top, a y value in the middle, and a z value on the bottom. And so that's what we're hoping for. If we don't get that, then we'll discuss as far as what happened and what the answer really means, how to interpret what the calculator is telling you. So now that we have our matrix, let's go ahead and open our calculator here. And if you don't have your calculator handy, you're more than welcome to just kind of follow along. But we got to turn it on, clear. Okay, so to start out, we have to get into the matrix and start up a matrix. So hit second, x to the -1. That's the matrix key. See the blue matrix? And now we want to edit it. We want to create something, so we scroll over to edit, and then we choose any one of those matrices that are available. You'll notice they have brackets around them, just like our matrix. That's because matrices have brackets around them. Alright, now, if you already have something here, you may want to choose a certain size. In this case, it is the number of rows. So this is going to go away, but this is the number of rows by the number of columns. Columns, remember, are up and down, and rows are across. And so when we hit enter to edit A, matrix A, it's going to ask us what's the size. It's 3 rows, 4 columns. Make sure that what you're looking at looks like the matrix you have. I have 3 rows, and then I have 1, 2, 3, and it cuts off all of the other columns. But if I scroll over, you'll see it's still there. Okay, and so all we're going to do is, as you enter these numbers, you're going to punch the number in, then hit enter after each entry. That will advance the cursor to the next column of the same row. When it gets to the end of a row, your calculator will, and you hit enter, your calculator will automatically go to the first column of the next row. When you get to the very end of the matrix and you put in your last entry and you hit enter, it'll stay put. So just be very careful. Okay, we'll check this when we get done. So I have 2, enter, -3, enter, 1, enter, 11, enter. Notice how it kicks back to that first column. Second row. So 3, 2, -2, 3. Kicks back to the third row. 1, 5, 2, 2. When I hit enter, it stays there because there's no other rows to kick to. So at this point, we need to check our matrix to make sure it's good. So I do it check by column. I'm going to run this a little closer to the matrix here. And so I check that first column, 11, 3, 2, 11, 3, 2, 1, -2, 2, 1, -2, 2, -3, 2, 5, -3, 2, 5. But in order to get back to that first column, I got to scroll back to the left, and I have 2, 3, 1, 2, 3, 1. Okay, so now I've verified that my matrix is in correctly. Go ahead and hit second quit to get back to the home screen. Okay, don't try to do anything within the matrix, because whatever you do within there will stay in there as a value, and you'll get an error. Now, we want to play with the matrix, so we have to go to second matrix. All of our matrix commands are in this particular menu. We want to do something, and to do it, we do math. And now we are looking for a command called row reduced echelon form, or RREF. Some instructors might say you need to use REF, row echelon form. What that does is it gives you this zero triangle on the bottom, but it doesn't give you that on top. You have to go back and solve it by hand. Since I'm using the tool, I'm just going to use the tool. And we're going to do it all in this row reduced echelon form. Will give you the answer that you need. So hit enter to select it, kicks you back to the home screen, and then it gives you that command at the ready. So now we have to call, whenever you have a function in computers, it's called calling a function. I want to use it. So we have to call our matrix. Hit the second key, matrix. To call a matrix, you stay in names and then select the matrix you're working with. Hit enter. At this point, you can close the parentheses. You don't have to. Just hit enter. And when you do, you have a matrix that comes up. So now, let me go ahead and find this room here. Well, actually, I'm going to do this. I'll put it over here, and then I'll bring our matrix back. Okay, so here we go with our matrix. And now you'll notice I have ones along the diagonal. That's what I was hoping for in this answer matrix. Ones on the diagonals, zeros everywhere else, but I have numbers on the ends. These numbers on the ends are the answers. And so I have 1 here, 1 here, and 1 here, zeros everywhere else. But then I have the answer of 3, -1, 2. 3, -1, 2. What this is saying in blue is that I have 1x plus 0y plus 0z equals 3, which tells us that x is equal to 3. And then I have 0x's plus 1y plus 0z's is equal to -1, or that y equals -1. Then I have 0x plus 0y plus 1z is equal to 2, or z equals 2. That's my answer. And so my point at intersection is 3, -1, 2. And that's how to use the calculator to work with systems in a matrix format. If you're dealing with 2 variables and 2 equations, you can do it by graphing in the calculator. You just look for the intersection. If, however, you're dealing in 3 variables or 4 variables and 4 equations, or 3 variables and 3 equations, or even more, matrices are going to be about the only way the calculator can do it. I do not believe that this calculator can graph in 3D. And so even if it can, once you hit 4 equations, you're in 4 dimensions. No calculator that I know of can do that. And so it just simply works better in a matrix format. And that's how you use matrices in the TI-83 and 84 calculators.